In Rust, it allows you to take a closure that you've defined in line and pass it as a parameter into another function. You have to go a little bit of extra. There's a little bit extra syntax, actually a little more extra syntax. More than I was hoping. I hope there would be a nicer approach there. Well, actually, let's take a quick peek here. It's quite repetitive. I'm looking at this real quick. Just look at this. We have a generic letter F, another generic letter F, and then a third generic letter F. They're all referring to the same. Of course, you might have multiple of these, multiple generic letters all over the place. It just feels like it's a little bit of extra that's required in order to get a function to be captured as an input parameter. That's what we're looking at, capturing a closure into an input parameter into a function. You can use it as a function. So while Rust chooses how to capture variables on the fly without type annotation, especially in closures, this ambiguity is not allowed within functions. When you define a function and you want to use that parameter and you want to make that parameter a closure, you have to go extra. When taking closure as an input parameter, the closure is complete, like all of it. Everything must be defined and annotated using a few traits. And it really depends on what's happening with the data that's captured within the closure in the upper level scope, which is extra confusing. The good news is the compiler will help you out, but it will also take you down the wrong road if you make some accidents. I was trying this earlier. It is still not that good from an error guidance perspective. If you do it wrong, it's going to be, oh, you want to do this. Oh, you want to do that. No. But if we walk through this, the compiler will determine what the closure does with the captured values and will attempt to apply the least restrictive. It looks for the least restrictive. On a variable basis, the compiler will capture the variables and look for the least restrictive manner. So if you capture multiple variables, so let's look at our closure here. We've got a closure diary. Takes no parameters. However, this closure, it does a couple of things. It captures greeting in a read-only state. That seems fair. That's fine. Okay. All good and well. Though it takes farewell and it mutates it. That's a problem. But then it goes a step further and destroys the farewell altogether. Now that mandates the compiler to expect you to write your function with fn once because you've destroyed this variable. So to make this work, you have to define the closure, the function, right? F, which is going to be our function. It's just like this here, function. Essentially, this is our diary, right? Diary, just to keep things simple. We've got our diary. We've got F function. It's an F once, mandatory F once, because it destroys the farewell variable. We mutate it and we destroy it. So then we can run this. Hello, then you screamed goodbye and now you can sleep. So what we can do if we wanted to prevent the requirement of an fn once, we don't have to permanently destroy farewell. We could just now update our code. I actually wonder, since we're implementing the most restrictive, but we've eliminated the need for the restriction, will it still compile? Or is it going to ask us? It still compiles. Interesting. So even if you implement the most restrictive on the closure, we should be able to do it as an fn mute though. Okay, with an fn mute up here, we can implement fn mute, but you also have to add this mute keyword here in front of our diary. And then that'll work because we're mutating farewell, which is a variable in the upper level scope. And then if we wanted to reduce the restriction even further into, let's see here, into just a function, so like this, we get rid of mute. Then we also have to eliminate this. We'll get an error here because we're mutating data. The compiler knows this because the diary is mutating data. The diary closure is mutating data here. So we'll just comment this out and that should compile. All right. How do we accept a closure as an input parameter in a function that the closure itself has the ability to accept a variable as another parameter? Well, you can do that with just a little bit of extra just a teeny bit of extra syntax. Let's take a look here. All right, this syntax is a bit extra. So say we wanted to define a closure that has an input parameter on it, right? Like a number, like X in this case is going to be a number. And then we wanted to pass this closure to a function that we've defined somewhere else in our code. And here's that function just above here. We'll call it apply to 3. It's going to accept a generic F type, which is a function type, this could be any letter. It's F for readability. F is the variable name, which is going to be essentially it's double is what this is going to be because it's double here. We need to say that it returns an I32. Also, we need to define the signatures of the parameters for the anonymous function itself right here, where the generic f is going to be a function that accepts an I32 as one of its parameters. So now we can pass our double function, that's a closure, into another function that can be able to execute that closure, but also pass a parameter to it, which is going to be an integer. So 3 doubled is going to be 6, because we're taking 3, passing it to our double. And we can also like say 10, or 100, right? So that should be 200 if I run. And that's 200, although, 100. All right. So this is really helpful when you want to be able to pass a closure, sort of like this anonymous function that you've defined with a variable name, so it's not so anonymous. This function, I suppose you could actually, I wonder, you should be able to put it here, right? So you didn't even need to define it as a variable. So now it's truly anonymous. Is it gonna work? I think it might. Okay, it works. So now it's truly an anonymous function that you pass in here, and now your function can take a closure that you execute. This is pretty powerful when you're writing code that's gonna be reused and functions that require a little bit of extra logic for things that are like this, where there's just a little bit of extra code or logic that you want to add into the execution of your function. You can do that using a closure, and this is a great way to do it. When I first started writing Rust, I was used to JavaScript and the higher order functions and the closures, and I wanted to be able to do this pattern. However, this kind of syntax in the early days wasn't very approachable, was much different than this, or even not even available. Now it is available. There's still a bit to it though. You still need to add a little bit of extra syntax. Understandably so, the compiler needs to know what's going on here.